Okay, piecewise pretest question number 2. Fill in the missing pieces to the piecewise function. Again, very straightforward, and then we have an extra question down here at the bottom. So you can see I have function 1 right here, and I have function 2 right over here. And function 1 is going to be the general rule of the quadratic. It is a curve, and it's starting at the origin. I know it's going negative, and we're used to seeing them in the positive direction, but just to show you that it could be done. The rule doesn't change. It's y is equal to ax squared. And you can see that right up in here, that's what they want. They want that a. So in order to get the a, we need to be able to do a substitution. We need an x and a y if we're going to find that a. And we're going to get the x and the y from a point. Now, can't use the zeros. The point over here, we don't have it. Turns out it's right here. So the question then becomes, well, can we get that point? Well, this is where the domain restrictions become important and the other equations become important. So you come back up here and always take a look at what we know. X is between 0 and 5 for the first function. The first function runs between 0 and an x of 0 and an x of 5, meaning the x over here at that critical point is 5. Remember, filling out those critical points after we have the general rule written down. So we know that the critical point there has an x of 5, and we also know its y component because we know the equation of this constant function is y is equal to negative 6.25. So negative 6.25 is the y component there. So that gives me the point 5 comma negative 6.25, which is right there, which of course is an x and a y, which then allows me to do a substitution to solve for a. So negative 6.25 is equal to a times 5 squared. So now we're going to do a little bit of simplification. Clear it up. I'll turn my calculator over to get that squared function. And I hope you can still make that out. Just move that over a little. So I'm going to square the 5 to simplify it. So 5 squared, and that's, 5 squared is 25. So negative 6.25 is equal to a times 25. Which is a kind of an ugly way of writing negative 6.25 is equal to 25a. That should look a little more familiar. Just switch those out. Doesn't really matter. Bottom line is you need to know that you got to divide. 25a divided by 25 over there, and over there will allow me to then say what the a actually equals. So clear. 6.25 negative divided by 25, and I get negative 0.25, which is the value of the a in the specific equation. Y is equal to negative 0.25x squared. That's my specific rule right down in there. Now what that's going to do is it's going to allow me to answer the question down here. If this is finished, I filled this in, but down here they want to know, hey, what's the value of y when the x is 3? Well, I've got a rule that allows me to do that. First of all, you got to figure out what function are we going to use, and you can see 1, 2, 3. The x is 3 right here. And so you have to decide, okay, I'm looking for that corresponding y value. Looks like it should be somewhere close to negative 2. But we need to know which rule to use. And because the 3 for the x is inside the domain restriction of the first piece of the function, that's the rule we're going to use. In other words, the rule I just found. So we're going to substitute x is 3 into this rule here. Y is equal to negative 0.25 times 3 squared. Y is equal to negative 0.25 times 9. 3 squared is 9. And clear that up. 9 times 0.25. Don't forget your negative. It's negative 2.25. So you can see it was close, so I was pretty close with my guesstimation there. It's about 2, I said. It turns out it's actually negative 2.25. And following those steps has once again allowed me to answer the question.